So I will tell you today something about timing within AutoSAR. I'm a member of the group work group resources that is uh, actually there to deal with timing. And I would like to see my slides now. Here it is. Thanks. So we introduced a new unified timing approach within this release 2211, and that's what I'm talking about today. And so, what does the workgroup resources do? Well, actually, timing is a vital part within resource constrained systems because it's also a resource timing, and you have to take care about it so that you don't lose focus on it. And that's why AutoSAR shall cover timing, design, and analysis as well. And so this workgroup resources was initiated by OEMs, Tier 1s, all major tool vendors like debugger vendors, trace tool vendors, timing analysis tools, and we all take care about the timing. So we even would like to have more feedback from OEM and Tier 1s. It would be very appreciated because, of course, these are the ones that are using the timing tools then. And to further integrate the whole timing-oriented process and methodology, we established a new concept within this release, and I will tell a little bit about that. So there is a timing development process, and we actually identified a gap in this development process. There was already a behavioral description with a textual timing requirement representation. We had the functional architecture analysis with the functional description within the VFP++. And then we had the software implementation with Timex, and we had the test and tracing with RT. And there was a gap between the VFP++ and the software implementation, which we addressed in this concept, which is about traceability, the description of the requirements on higher level, the decomposition rules, and then, of course, the timing analysis itself. So we established this unified timing and tracing, and this is the new release elaborates a unified approach for timing analysis, design, validation, and verification, including the definition of a suitable tracing method, which can be applied to classic and adaptive platform. This covers to build up a timing reference platform and to extend the timing description to different abstraction levels. So what does this all mean? And that's what now the next slides are talking about. So there is a timing and tracing approach within AutoSAR. So we have this timing design, which is based on best practices and use cases. We have then to specify the timing constraints, and then, of course, we have to record or test the timing constraint, which is then done by tracing events in the software or by logging the events. And then, of course, we have to analyze the timing. And this methodology is covered by subgroups within AutoSAR. We have this timing analysis and design. We have Timex for the timing description. We have RT and LT for tracing. And again, the timing design, TAD. And as you can see, we have TAD at the beginning and at the end. And this is definitely there to show that this is a round trip engineering something. And we want to establish actually an automated and tool-based process upon that. So we also established a so-called timing reference platform to validate and demonstrate the timing-related AutoSAR specifications. The TRP consists of an adaptive platform part and a classic platform part to cover both. The adaptive platform part is, of course, based on the adaptive platform demonstrator on the latest release, and the classic platform part is there with a full system description to be able to reconstruct the system. And both then use classic platform and adaptive platform server-oriented communication. And that's not only theoretical. We have, for example, here two practical implementations and test setups where we actually test our specifications with. And you see this guy hunting the timing with some RT hooks. So how does the system and timing design look like in the TRP? Just as an example, we have a sensor, the pedal here, and we have an actuator, which would be the brake. And then we have timing requirements, for example, 150 milliseconds and some detailed timing requirements. And now the whole methodology gives you the possibility to decompose this into further levels. Just showing you one level here, but you can even go further down into detail, into runnables or even function level design. So how is the methodology if you do tracing timing events in classic platform, for example? So at first, we have the timing design or the timing model, and then you can detail this with the so-called Timex events and constraints. By doing so, you get a system level timing constraint definition on Timex. Then these Timex events are mapped to RTE VFB trace event callouts. So you got the RTE VFB trace. Those in turn are mapped to RT trace hooks for a very efficient recording of the events. So out of this, we get the RT trace. And out of the RT trace, you can then feed an extensive timing analysis. The export of the RT trace is actually done by a different specification upon ASAM, but they go very close hand in hand to provide this sophisticated timing analysis done. How does this look like in adaptive platform? Well, again, we have this timing design model. We have, again, this detailing in Timex and the system level constraints in Timex. Then the Timex events are mapped to log and trace messages. And so you get these ALACOM log and trace calls. These are mapped to RT trace, again, for efficient recording. And then you get the RT trace. And then we are recording this and feeding this to the timing analysis. And if you're looking closely, this looks very much pretty the same as in classic platform. That's exactly why we call it unified timing and tracing approach, because it's a unified method how you can do it on classic platform and adaptive platform. So what does AutoSort provide now for timing? A standardized timing design, both on system level and on platform level. Then you can specify the timing constraints, event chains, whatsoever, both on classic platform and adaptive platform. On classic platform, you can trace then the operating system with RT, and you can trace the runtime environment with VFP trace and also with RT. On adaptive platform, there is still some work to do. There is another concept that deals exactly with this to have the possibility to trace the operating system, and also to trace application and functional clusters with log and trace environment. And then there is also the possibility to have the user-based event logging with AdaLog. As I told you, we want to have that automated, so the automatic timing analysis is still work in progress. So what's the conclusion? We as workgroup resources, we deliver everything what good timing needs, both in design and analysis. So the methodology is now defined in the release 22-11. However, we would need some feedback from real applications so that we can continue to improve the standard. And so we need volunteers, we need input from you users to still further develop and improve the standard. So what's next? We actually want to use the timing reference platform, which we already have, but we want still to implement everything to have a complete methodology as a validation for us and as a blueprint for other timing projects, for user timing projects, for example. So that's actually already what I wanted to tell you about the new concept. And the most important part is that I really would like to stress the message that timing is a very important part within this resource constrained systems, and you should take care of it. And AutoSAR gives you actually everything you need about that, including a tool-based method to test and validate your timing. And that's it from my side.